Okay, here's our circuit all built up. This is plus 12, actually, going into the rail here. Ground onto this inner rail. And as it turns out, ground on this inner rail and minus 12, but we don't actually need to use these two because we only require the 12 and ground. And then to review, I have set this potentiometer by hand, so it's about 50K, and dialed it in to get the right voltage. I'm only using the the lower two pins. Then following through the pot, we go to the second pot. So the pot here, the large one, which is a smaller value of 10K, is split 5K, 5K approximately, with the 2-volt output is in the yellow wires, goes through the switch, and then is combined on this row. The center pin of the 10K pot gives 1-volt output, and that's on the blue wire in my case, that then goes to this push button switch and combines on this rail. And then the final button simply connects ground to the push button, and then I have a 10K resistor that goes over to that same combination rail, and that's where I'm measuring right now. One last thing to note is don't forget, even if you separate the ground for the push button, for the ground from the bottom of the pot, it doesn't matter. I don't put the push button here, I put it physically down here just for my convenience. And of course I'm measuring VTH 0, 1, or 2 volts with respect to ground here on my voltmeter set to a 20-volt DC max. Let's see how it works. So there's ground, I'm pushing this one down. Of course I read 0. Well, I read 0 anyway, but this definitely drives things to ground and makes a connection directly. Or I guess through that 10K protection resistor, but of course that doesn't change the ground voltage any. So that's the configuration now. Now let's do the exciting one here in the middle. I'm getting 1 volt when I push this one down, so it's my 1-volt output, and then the top one push down, and of course I get the 2-volt output over here. What happens when I do add a load resistor? Let's check first of all by trying it with a MOhm, since that is the desired load resistor voltage. Here is a 1 MOhm resistor, and the way I will test this is by taking this MOhm resistor and attaching it to ground. So 0 volt still, 1 volt still, and 2 volts still. I have not dropped at all my voltage because of the 1 MOhm load resistor. And do a quick demonstration of that by actually pulling it here with it in. And you see that the change is down 2 orders of magnitude. I expect the change to be about 1% or so because the Thevenin resistance at 2 volts is about 10K, which is about 1% of 1 MOhm, and that's why I changed there by 0.02 volts or 20 millivolts. So again, this symbolizes the entire VCO input at a MOhm, and my drop is only 1%, which is as designed. I can repeat that for the 1 volt, 1.02, I pull it, not really able to measure a change on this 1 volt. That in part is because my internal source resistance is less, and 1% or so of 1 volt doesn't really show up on this meter. I'm going to give you a little closer up look at my circuit before turning off the video. Again, the 500K pot set to about 50 is only using 2 of the pins. The yellow output of that goes through this push button. So that's the yellow wire. The blue wire is from the center pin of the 10K pot, combining down here. And then the black wires are reserved for the ground with the 10K protection resistor going to my output, which is the green color. Just a couple more views of how that all looks and works. Turn off the power supply and give everyone one more look at my device here that I use as a breakout board for powering a breadboard at plus 12 ground, and minus 12 volts off of a Eurorack power supply. Remember, I've been using the convention. It's a little confusing that the red stripe is minus 12, so the red stripe actually went into my blue wire here, which I did just to match up with the color on the breadboard better. Here on the other side, again, is what it looks like. And one last time, my low voltage divider circuit with push button switches.